Section 1.7, number 34. We're given two functions. F of x is x plus 3 over x minus 2. G of x is 2x plus 3 over x minus 1. And we're told to verify that these things are inverses algebraically, graphically, and numerically. I'm going to concentrate on algebraically and graphically. I'm going to talk about numerically based on the graph. Alright, so to determine whether or not these things are inverses, we take one of the functions, put it in the other, and we see if we get out just our input variable x out at the end, and then we flip it around, do our algebra, and determine if we just get x out at the end. Alright, so let's look at f of g first. Okay, so now we take the entirety of g and stick it wherever our x was. Okay, alright, so for this we're going to get the quantity 2x plus 3 over x minus 1 plus 3 on the top. On the bottom, we're going to get the quantity 2x plus 3 over x minus 1 minus 2 on the bottom. Okay? Alright. Now, we can handle the top and the bottom separately by multiplying top and bottom, our 3 by x minus 1 over x minus 1. Okay? Our 2 by x minus 1 over x minus 1. Okay. Now, what this gives us is this gives us a 2x plus 3 over x minus 1 plus 3 times x minus 1 over x minus 1 on the top. On the bottom, we're going to get 2x plus 3 over x minus 1 minus, I'm going to go with a negative 2 times x minus 1. I think that's going to be a little easier to deal with. Addition is going to be easier to deal with, and this minus 2 I can distribute in, and we still have our x minus 1 on the bottom. Okay? Alright, so now we can combine these fractions. I can get on the top, we're going to get an x minus 1. On the bottom of the top, the remainder, we're going to get a 2x plus 3. And we're going to get 3 times x is a plus 3x. 3 times a minus 1 is a minus 3. Oop, I'm running out of room there. Okay, so that's what we have on the top. On the bottom, we have an x minus 1 on the bottom of the bottom. We're going to get a 2x plus 3. Again, at a minus 2 times x is a minus 2x. Minus 2 times 1 is a plus 2. Okay. Now, can we simplify these? Okay, can we cross out any common terms? So we're going to have plus 3 and a minus 3 on the top. The plus and the minus are going to cancel out nicely. We're going to get a 2x and a 3x is going to be a 5x on the top. Okay, and that's still over our x minus 1. Okay. On the bottom, we're going to get a plus 2x and a minus 2x, so those pieces, the addition and the subtraction, are going to cancel. And we're going to get a plus 3 and a plus 2, leaving a 5, and that's still divided by an x minus 1 on the bottom of the bottom. Okay. Now, we have a fraction on the top and a fraction on the bottom. If we reciprocate and multiply the bottom, the top stays as a 5x over x minus 1. The bottom of the bottom comes to the top, x minus 1, and the top of the bottom stays on the bottom. Okay. Now we have an x minus 1 on the top and an x minus 1 on the bottom, and now this is a multiplication of two fractions. If something is on the top of one fraction and the bottom of the other, because it's a multiplication, those will cancel out, leaving us with a 5x over 5, and the 5 on the top will cancel out with a 5 on the bottom, leaving an x, and we are good. Okay, so f of g leads to x, and now we need to do the same thing for g of f. Alright, so g of f means we take the entirety of f and replace all of the x's in g with our f. So we're going to get 2 times the quantity, x plus 3 over x minus 2, plus our 3 over, instead of x, we're going to get x plus 3 over x minus 2 minus 1. Okay, now we're going to play the same game we did last time. We are going to get our common denominators by multiplying by x minus 2 over x minus 2 times this 3. And this 1, we're going to get, the hell, sorry, that should be a 2. X minus 2 over x minus 2. Okay. Now we got these things that are we have the right thing on the bottom. So on the bottoms, on the top, we're going to have an x minus 2. We're going to have a 2. We're going to have to distribute into the top only, because we can think of this as a 2 over 1, this is a 3 over 1, etc. So we're going to get 1 times the bottom, but 2 times the top. So we're going to get a 2x plus 2 times 3 is 6, plus 3 times x, which is 3x. 3 times a negative 2 is a negative 6, and that is all on the top. Okay. On the bottom of the bottom, we're going to have our x minus 2, but we have a 1 times this and a 1 times that. Now the only thing we have to keep track of is this minus sign, which we've all seen is my problem. Right? So we're going to get an x plus 3. Now this minus is going to distribute into both places. So we're going to get a minus x minus a negative 2 is a plus 2. Okay. Now, can this be simplified? Well, we're adding and subtracting a 6. Those will go away on the top. We're adding and subtracting an x, so those will go away on the bottom. 2x plus 3x is a 5x over our x minus 2. 3 plus 2 is 5 over the same x minus 2. Okay. Now we do our trick where we reciprocate and multiply the bottom. So we're going to get a 5x over x minus 2 times x minus 2 over 5. Okay, now we have multiplication, which means that if we have one thing on the top of one fraction and the bottom of the other, they will cancel out, leaving us with a 5x over 5. And a 5 on the top of the fraction and a 5 on the bottom of the fraction. This is now multiplication. Multiplication and division play nice, so we can cancel those out, leading to an x, which means that these two things are indeed inverses. So that's the algebraic part. Now let's look at the graph and talk about the numerical side. Alright, so here are the graphs of our functions. In blue, we're going to have our f of x, which is x plus 3 over x minus 2. And we see that this thing has a vertical asymptote happening here at 2. Okay, because when x equals 2, the bottom is going to 0. Right, so that's going to be its blow up. In the red, we're going to have 2x plus 3 over x minus 1. This thing is going to have a blow up at x equals 1 because that's where its bottom is going to 0. Okay, so graphically, they are inverses if they are symmetric across the line y equals x. Right, that's our green dashed line here. Okay, basically, if you take the paper and fold it along the line y equals x, f has got to map to g, and g has got to map to f. Okay, they'll fold on top of each other. It's this origami problem. So if we look at this, it definitely has this mirroring across the line y equals x, right? We're exchanging y and x, so it makes sense that x and y would be our mirror for that. Now, as far as the numerical part, basically the idea is that if AB is on the graph of F, then BA has to be on the graph of G. Okay, so let's look at a couple points here. Okay, so the point -3, 0 is on the graph of F. F has the point -3, 0. Okay, if 0, -3 is on the graph of G, we're in good shape. Okay, well, we look at 0, we go down here to -3, the point 0, -3, and sure enough, by golly, that is on G. Okay, if we take a point that's on G, for example, the point 6, 3, right? G has the point 6, 3 on it. F should have the point 3, 6. Okay, well, we go over 3, we go up 6, and sure enough, 3, 6 is on F. Okay, so when we say verify numerically, right, we get this table of X values, this table of Y values, and if by switching from F to G, all of our X's become Y's in our table and all of our Y's become X's in our table, we should get we'll get an inverse function. All right, so that should do it for inverse functions. You know, the things to test: can you verify? Do you know what they mean graphically? And can you find them? So, good luck, good practice. Hope you're having a good weekend.